All right, ladies and gentlemen, a student requested some assistance with a Chapter 3 quiz, problem number 28. Okay, so here's the problem. Talking about SAT scores. The average national SAT score is 1019. Now we're going to assume that it's a bell-shaped distribution. Now remember, if you assume that it's a bell shape, otherwise known as a normal type distribution or normal shape distribution, then we can say more about it. If we didn't say that, if we did not say that it was a bell-shaped distribution, we could still use Chebyshev's theorem, but it would not be as precise. In any event, the problem says if we assume a bell-shaped distribution, we assume a standard deviation that's 110, so that's a standard deviation, that's my S or my sigma equal to 110. What percentage of scores will you expect to fall above 1129, above 799? Now, the first thing you should notice here is that 110 plus 100, I'm sorry, 1019 plus 110, that's 1129. 1019 subtract 110 is 909. Subtract another 110 and we're at 799. So what this boils down to is 1129 is plus 1 sigma. 799 is minus 1 sigma. It's plus 1. Gosh, I said that wrong. Let me start over. We start with mu. Mu or the mu is, or the mean is 1019. 1019 plus 1 sigma is 1129. 1019 subtract 2 sigma is 799. So that's where these numbers are coming from. Okay. All right. Now all of this is explained in your textbook, roughly speaking, on page 141. So let me bounce to that. Okay. All right. So here we are on page 141. First of all, it's talking about, this is approximately. Here's Chebyshev's theorem is on page 141. All right. So we talk about Chebyshev's theorem. You see, Chebyshev's theorem, the shape of the distribution can be anything. However, if we can say that the shape of the distribution is bell-shaped, then we have better information. Okay, and here it is. So the Chebyshev's theorem applies to any distribution. However, if a distribution is bell-shaped, it's often called normal. It's a terrible name, but that's what they call it. All right, so it's called normal. The following statements, which is the empirical rule, these are true. So here it is. So that's on page 141 approximately of your textbook. You can freeze the screen here. You can read that for yourself. No reason for me to just read this to you. Okay, and they even give an example here. They give an example that's very, very similar to what the problem is. So my advice is always the same. Work your way through these examples, pencil and paper in hand. That's how you're going to learn this stuff, okay? Trust me on this. I have not lied to you yet. Okay, so here's a nice cartoon that kind of tells us what's going on here. The concept is very simple, that if it's more or less a bell-shaped distribution, you've got your x bar. Is it x bar or mu? Do you remember how that goes? X bar is if we're talking about a sample, mu if we're talking about a population, but the rule is the same. So here's x bar plus 1 standard deviation minus 1 standard deviation. So it's plus or minus 1 standard deviation. How much is between minus 1 standard deviation and plus 1 standard deviation? Well, there's 68%. Well, if there's 68% between here and here, well, it's bell-shaped, so half of it is between x bar and 1 standard deviation. Half of the 68%. So what is half of 68%? Half of 68% is 34%, okay? So 34% is between x bar and 1 standard deviation. How about between x bar and 2 standard deviations, between here and here? Well, if there's 95%, right? Look at these little bars up here. There's 95% between x bar plus 2 standard deviations and X bar, subtract 2 standard deviations. There's 95% between here and here. So half of 95% is 47.5%, right? Let me double check that. Yeah, I had to double check that with my calculator. You know, I'm retired from Northrop Grumman, and I still can't do arithmetic. Okay, so if you have problems with arithmetic, don't despair. It's not that big of a handicap. Okay, all right. So there's 47.5% that's between here and here, between X bar and 2 standard deviations, and then similarly, because it's symmetric, anything you say about the right-hand side, you also can say about the left-hand side. So having that in mind, let's see if we can do this problem. I think we're going to be able to see the problem is really not hard at all. Okay, so here's my excuse me, sorry for the delay. Here's my handwritten solution that I wrote out. Okay, so here's the format I always use. I write down what is it that I'm given. I'm given certain information. And then I'll say, what is it that I'm supposed to find? What information am I looking to find? Okay. And then I always put a page number at the bottom. Okay, so what I did here was I just printed out more or less of that same page. This is from edition number 9. I've got the P, or no, I take that back. This is from the current edition. Okay, so here's the information. I printed that out. You know, it won't kill you to do that yourself, right? I mean, you know, you just uh, copy certain pages that have very good information for you. Okay. All right. So let's move down here. Okay. So it's on page 141 about the empirical rule. You assume that it's approximately Bell, but this is what we know. Okay. 68% is within 1 sigma, 95 is within 2 sigma, and so forth. So for example, 68 for our problem is our standard deviation is 110. So if 1019 is our mean, 1019 plus 110, that's 1129. That's what we're looking for. That was the call of the question, was what is above 1129? Okay, so again, I just draw my little cartoons here to refresh my memory. Between 1129, that's plus 1 sigma. 909 is subtract 1 sigma. There's 68% between here and here. Therefore, there's 34% between here and here, right? Okay, so how much is above 1129? Well, if there's 68% between here and here, there's 34% between here and here, okay? It's just a matter of drawing these cartoons, you know, and it probably wouldn't be a bad idea to shade them in as well. But between here and here, there's 34%. So if there's 34% between here and here, how much is left over? How much is to the right? Well, there's 50% all the way to the right. So 50% subtract 34% is, that's what I'm saying right here, 16% is to the right of 1129. So the final answer is 16%. That's what the question called for. Okay, well, similarly, if you want the percentage above 799, well, 799 is 2 sigma less than my X bar. That's this way, it's 2 sigma, right? Because 1019 subtract the 110 puts me at 909, subtract another 110, I'm at 799, okay? So just say it all at once. To the left of the mean, 2 sigma is 799. Well, how much is between 799 and this guy over here, the 1019 plus 2 sigma? How much is there? 95%, just like we said before. So half of 95% is between 799 and 1019. Between here and here is 47%, 47.5%. Thus, to the right of 799 is so between here and here is 47.5%. From here all the way to the right is 50%. Okay, so between here and here is 47.5%. From here all the way to the right is 50%. So add those two up. So we get 50% plus 47.5% or 97.5%. So that's our final answer. So really it's the cartoons. The cartoons tell you everything you need to know on this kind of a problem. This is an important problem to be able to handle. You need to be able to do these kinds of problems because later on when we talk about what's called the standard normal distribution, it's what's called a continuous distribution. We're going to be doing these probabilities using these kinds of curves. So you need to understand how to do these cartoons and how to find these areas that are underneath the curves, okay? So please make sure you understand how to do this kind of a problem. Thank you. That's the end of this tape.